Alright guys, and does this make a better image then in your head of how the sun moves? Do your pictures, your predictions, do they look anything like this? Yeah? And maybe the shadows, does this make more sense now? And what we were going to do, I put that picture over the top. Since it's a cloudy day, we didn't get to do this. We were going to have you guys go outside and trace yourself in chalk at 3 different times. So this is, the example here at the top is shown is the first tracing was probably, I'm assuming, whenever they got to school or early. And the second one was probably, hopefully around either close to noon. That's how much their shadow changed. Okay, now this is the difference with summer and winter then. We were talking a little about that, with how the sun is higher in the summer and lower in the winter. And down at the bottom it shows the shadow lengths and the solar angle in the season. So for summer, fall, winter. So if you chose fall as what you were going to draw, you would probably be in between that summer and winter drawing. That's how high your sun should be in the sky when it's moving across. Okay, and we're going to make sundials here in a second. And I brought this up. Yep, I'm going to cut it out. So these are different sundials. The sundial right on the top left, that white one, that's one that can be used day and night. Way back before the 1800s, this is what they used, solar time. This is how they were able to predict what time of day it was. Now, the problem that actually happened why we switched to standard time, in 1883, with the railroad, like with the trains and everything, they needed to have a solid time schedule. So what they did was they needed to make a time that was going to be across the board for everyone. Because sometimes, say here, when we were at 12 noon, if we were in Indiana, in Fort Wayne, and we were at 12 noon, in Indianapolis, or somewhere 40 miles away from here, it was 40 minutes either the other way, either 12:40 or it's 40 minutes before that, because of the sun movement. Where that shadow was, the shadow's going to be different in different spots. It's constantly changing, so it's just off. So they had to get something solid, even though it's going to be a little bit off time-wise. Maybe the next city over would have been 4 minutes different. They needed something that was solid. So that's when we started doing standard time and kind of getting away from solar time. Just because it was just too hard. But it still works. It's pretty accurate. It's still pretty close. And we'll make sundials, and I'll pass it around. You guys can be in your groups. You can use flashlights and kind of move it, pretend it's the sun in different stages to kind of get a good idea of... What, Jack?
Huh? What? I didn't roll my eyes.
Okay. Kind of get an idea of how a sundial works and how you can kind of manipulate it. Yeah, Tommy? That's okay. Does anyone have any questions about sundials, or have anyone used one before?
Oh wait, no, I remember.
Okay, Tommy.
I went to a solar time. Well, it took me a while to learn, but now when I look at the stars, I can tell what time it is, like the exact time.
The stars?
Yeah, I know.
How do you do that?
Well, I got this book, and it's really hard to explain, but I can know now if I have I can see the stars, like if I use this telescope, I can tell what time it is.
That's interesting.
Wait, can you bring your book in?
Yeah, maybe you should bring the book in
No, it's a
someday.
library book. I turned it in like a while ago.
Okay. Well, Bailey, what do you have?
I have a question about how the sun moves.
Okay.
Like, so if it's the winter time, does that mean like the sun would like go down sooner?
Yes.
Yeah.
Well, and then, like now we switched over. Everybody knows now we're going to fall back because now we're using daylight savings time, which is probably, I think it's in like a week or a couple weeks we're going to switch.
It's on November 11th this year.
Okay, so a couple of weeks, which gives us an hour. But it's just because of how the sun's dropping in the sky for that angle, the angle of the sun. Is that what you're? I'm having a like. Is that what you're trying to get at, or is that our days are shorter
Well,
because of that?
I was just wondering like how it gets, like how the sun goes down sooner, like the angle.
Does anyone know? Does anyone have a good idea? Emily?
Don't we, in the middle of the year, don't we like change the time in an hour? Yeah.
Well, that's daylight savings time. Yes, we do that same. Does the Earth tilt a different way?
No, it rotates around the sun.
No, it's
No.
it's falling into.
Jack?
Well, it's tilted and we're spinning on the Earth while going in a large circle around the sun. That's how we get here in our seasons.
Bailey, you have a question?
Oh, no.
What do you think?
Isn't it like the sun is like more like farther away from the earth or something? No.
Does the sun move?
No.
No. And we don't move, do we?
Yeah.
The Earth moves?
Yeah.
Because we move with the earth. That's fine.
Yeah.
Aren't we on
No,
Earth?
the Earth moves
Yeah,
and the
but
sun stays
like
still.
the
Earth moves like this and we go around.
One at a time, guys. Hold on one at a
But
time.
you can't tell because everything that like you build and stuff, it's on the earth and it turns with it. So basically you can't tell unless it's a shadow. If you know how, if you want to know it's like in the trick.
No, I don't. Caroline?
Well, the Earth is on an axis, and it spins like that, and it also goes around the sun. But the sun doesn't move, we move, so the shadows change.
Okay, I think you guys are onto something. I think you guys have some good ideas. Colton?
So the sun is right here, and then we're over here, and then we are spinning round and round and
No, I
around the
guess.
sun.
No, we're going around the sun.
Why?
He's right. He's right. We do move. We do move around the sun.
We move like 2 times. Well, like
takes, like,
we're
years to go
still
around.
spinning around the sun while the Earth is also spinning.
We're still spinning around the sun. Well, you mean we are? Yes, yes. We always rotate. We're always rotating as we're rotating around the sun. Hunter?
Well, doesn't it take a year to get all the way around the sun?
It takes 24 hours.
No, that's
No,
good.
no,
That's
that's-
the rotating.
And it's, maybe this is a good point then, because what Hunter's saying is, do you think that affects how the sun is rising in the different stages during our fall, winter, and spring and summer?
Because we go around in a
Yes.
What, Tommy? What do you?
I don't, it wasn't the book with the solar thing, but I read in another book that I like astronomy a lot. If the sun is not like completely in the center and the farther away is the colder the earth gets and the closer we get, that the warmer it gets. So
Well, it's how the Earth is tilted. That's why in warm, like the Caribbean and Gulf of Mexico, different places where it's warm. Is that why maybe you think it's warmer there because the sun might be closer to the Earth?
Okay, so how come when it's like we get snow here and like rarely in Arizona they never get snow? Or
Why do you think that?
I don't know.
Oh, I
That's
know.
my question.
Bryce?
I think it's because the southern hemisphere is closer to the sun, and then the northern hemisphere is tilted back, so it's naturally colder up here.
That's why you
Yeah.
have these
Tennessee's
That's good. You guys are doing great. You guys are doing really great of thinking, using your heads to kind of explore this idea. Yes, Jess?
So back to the Bahamas and stuff.
Mm-hmm.
Does it have something to do with being next to the equator since they get a whole bunch of sunlight there?
And that's kind of what Bryce was. That's exactly along the same lines that Bryce was talking about. Yeah, Karen?
Isn't the equator warmer because it's the closest to the sun?
Yes. Yes. See now, is this all kind of combining together, guys?
Yes.
Meshing, making sense of why these things happen. Sierra?
Well, I just have a question about the Bahama thing. Like, if the Earth is turning, how come they don't have like seasons? Like, if it's turning.
It's because of where we're positioned.